I regularly get calls from customers asking how to calibrate an ORP electrode. ORP electrodes are not calibrated in buffers the way you would calibrate a pH electrode. ORP is a qualitative rather than fully quantitative measurement. This often frustrates the user who may be expecting something different. ORP electrodes can be tested to verify that they still maintain a proper output level. I'm Joe Ewak with SensorX. Join me today as we uncover the mystery of how to calibrate ORP sensors. SensorX provides several premixed aqueous solutions with fixed millivolt output. Most popular is known as Zobel solution with an ORP reading of 230 millivolts. I've placed a sample of Zobel solution into a small container. I've connected my ORP sensor to my ORP meter. You might connect yours to your transmitter or controller if you're using that instrument. Place the sensor into the Zobel sample, giving it a quick stir for a few seconds, letting the readings stabilize. Make certain that your meter is reading on the millivolt scale. In this case, we're reading 229.6 millivolts, very close to the targeted 228 millivolts. For ORP, the tolerance is plus or minus 10%, so if you're within 20 millivolts of the target reading, you're doing real well. Some brands of ORP controllers actually require the user to program in two standardized ORP millivolt readings. Two-point verifications of ORP sensors can be made. SensorX offers 450 millivolt solution and also 600 millivolt premixed verification solutions. One of these, used with the Zobel solutions, will provide the two-point calibration method necessary for those controllers. Another option is for you to use SensorX ORP verification kit, part number B125. This kit permits you to prepare solutions with two different ORP values. The kit includes a powdered chemical known as quinhydrone and pH buffers 4 and 7. Add a small amount of quinhydrone to some number 4 buffer, stirring to get it to dissolve, and do the same and add quinhydrone to number 7 buffer. The saturated buffer solutions will have specific ORP millivolt outputs. At 25 Celsius, the 7 buffer will have an ORP value of about 90 millivolts. In this example, my ORP sensor is outputting something close to 82. As long as we're within plus or minus 15%, the readings are known to be good. Do a second check, rinsing the electrode in rinse water, and then place the ORP sensor into the quinhydrone saturated number 4 buffer. The number 4 buffer should have an ORP value of something close to 250 millivolts, plus or minus 15 millivolts as tolerance. In this example, we're up to just over 152 millivolts. So we have a known good ORP electrode providing 2 points of calibration. The two-point verification step will ensure that the ORP sensor is still working properly and meet the requirements of those ORP controllers that require 2-point inputs for standardization. SensorX also offers convenient foil sachets that provide the same 2 points for ORP calibration. The contents of a single sachet packet is opened and added to 100 milliliters of clean water, stirring briskly for a few seconds to dissolve it. We have 1 sachet equal to the 7 buffer saturated with quinhydrone, and a second sachet equal to the number 4 buffer saturated with quinhydrone. Output readings are the same as discussed earlier when mixing quinhydrone into buffers. Remember that all quinhydrone solutions are stable for only about 4 or 5 hours. They should be safely discarded when your testing is completed. Thank you for joining us today, and we hope we've shed some light on solving the mystery of ORP sensor calibration.